Hello everyone, welcome back to the series of Chapter 5 exercises from BUS 325 investment course. In this particular video, we are going to look at the last selected exercise for this chapter, exercise number 12. So let's read the question together. But first, as you can see, there's a very important note here at the top before this group of questions starts from 12 to 16 that says, assume that you manage a risky portfolio with an expected rate of return of 17% and a standard deviation of 27%. The T-bill rate or the treasury bill rate is 7%. Okay, and you're going to see how these pieces of information are going to be very useful for us to answer this particular exercise. So the question says your client chooses to invest 70% of a portfolio in your fund and 30% in a treasury bill money market fund. A, what is the expected return and standard deviation of your client's portfolio? Now, we've covered a similar requirement in the previous exercises, so let's get that done first out of the way. We said that to determine the expected rate of a portfolio that is made up of one or at least two components or more, then we are going to multiply the expected rate of return of each component of the portfolio by its weight within the portfolio, right? So let me just write down the formula to remind you. The expected rate on a complete portfolio is going to equal the weight. Okay, let's say, just like this example, we have a portfolio, so let's call it the weight of P of the portfolio, or the weight of the portfolio multiplied by the expected return on said portfolio, okay, plus the weight of the risk-free assets, so let's call it F, multiplied by the return on the risk-free assets. All right. With this, as you can see, we can just substitute and solve our question. The weight of the portfolio, based on what's given to us here, is going to be 70%, so that's 0.7 multiplied by the expected return on the portfolio, which is 17%. So that's 0.17 plus the remaining 30%, which is 0.3 weight, is going to be allocated to the treasury bill, which returns, or is expected to return, a 7%. Okay, so that's 0.7, or sorry, 0.07, okay? All right, now let's run the numbers in our calculators. I'll open a bracket and then 0.7 multiplied by 0.17, close the first bracket, plus another bracket, 0.3 multiplied by 0.07. That's going to be 0.14, which is equal to 14%. Okay? That would be the expected rate on the portfolio of that investor. Now, the second part of the question says, what is the expected return? That's what we just calculated. And also, what is the standard deviation? Okay? Now, we already know the standard deviation of our portfolio, okay, or the risky portfolio, is expected to be 27%. But there's nothing in the question that tells us what is the standard deviation on the treasury bill, right? But because the treasury bill is considered a risk-free asset, then we assume that the standard deviation of any risk-free asset is 0%. Okay? So knowing that, we know that the standard deviation on the complete portfolio is again going to equal the weight of the risky asset multiplied by the standard deviation of the risky asset plus the weight of the risk-free asset multiplied by the standard deviation of the risk-free asset. Now, because this is 0, then all of this term is going to go away, right? So all we need to do now is calculate the numbers on the left side of the equation, right? So just substitute here the weight. We already know that it's 0.7, which is 70%, multiplied by the standard deviation of the risky portfolio, which is 27%. Okay. You can either put it in a percentage format or a decimal format. It doesn't really make a difference as long as you know what you're doing. Okay. I'll run the numbers. 0.7 multiplied by 27%. That's 18.9%. Okay. So that's the first part completed, requirement A. Let's now look at the second requirement, part B. It says, suppose your risky portfolio includes the following investments in the given proportions: stock A, 27%, stock B, 33%, and stock C, 40%. Okay. Now bear in mind, these are the proportions of each asset or each stock within the portfolio, right? So these are not expected returns. So if you would imagine the portfolio as a pie chart, let's say, then it's going to be split into a 40% component and then 33% component and a 27% component, right? So that would be 40, 33% and 27%, right? 40 is for stock C, 33 is for stock B, and 27% for stock A. All right? What are the investment proportions of your client's overall portfolio, including the position in treasury bills, right? So now just to visualize for you, the investor's portfolio is going to be made up of what? It's going to be made up of two components. 30% is going to be in T-bills. Okay, that's 30%. And then the remaining 70% is going to be in the risky portfolio. Okay, and the risky portfolio is made up of those three stocks, stock A, B, and C. So as a result, the investor is also going to own a proportion in his portfolio is going to be allocated to stock A, another proportion is going to be allocated to stock B, and the third proportion is going to be allocated to stock C, right? So if we break this down, that means the investor's portfolio is going to contain 4 components: stock A, stock B, stock C, and treasury bills. So what is the question is actually asking you to do here is figure out that since the investor is only allocating 70% of his portfolio to the risky investment, which contains these 3 stocks, add these weights. Based on that, how much each stock is going to represent out of the investor's portfolio. Okay, I hope that clear before we move on. So now let's run the numbers and see what do we get. The investor's portfolio, okay, here I'm gonna write investor portfolio is gonna contain T-bills, okay, and it's going to contain stock A, stock B, and stock C. Okay. Here, I'm gonna add another column. I will call it allocation. Right? Now the allocation in the investor's portfolio to treasury bills is already given to us in the question, which is 30%. Right? All we need to do now is figure out what would be the proportion allocated to each of the three stocks. Right? Now, knowing that the investor is allocating 70% of his portfolio to the fund that contains these three stocks, that means we can figure out their allocation in the investor's portfolio by multiplying the 70% rate to the weight that each stock represents in the risky fund. Okay, so here we'll say 0.7 multiplied by stock A. Stock A's allocation is 27%. So 27%. And again for stock B, 0.7, which is 70%, multiplied by 33%. Okay, and finally for stock C, 70% multiplied by 40%. All right. Now we just run the numbers. 70% multiplied by 27%. That will give us an allocation of 18.9%. Okay, for stock B, multiplied by 33%. That will give us 23.1%. And finally, for stock C, that will give us an allocation of 28%. Okay. As a final step, just for you to make sure that you've got the right numbers, I would recommend you to calculate the total and make sure that it equals 100%, right? So 30 plus 18.9 plus 23.1 plus 28. And I got 100%. Okay? So that's the second requirement in the question, requirement B. Now, let's move on to part C and see what the question is asking for. Here, C, what is the reward to volatility ratio, Sharpe ratio, of your risky portfolio and your client's overall portfolio? Now, this should be easy. In order to calculate Sharpe ratio for any investment, we need to know its risk premium and the standard deviation of the portfolio's excess return. So let me first write down the formula, and then we will substitute and figure out our answers. Okay? So Sharpe ratio equals risk premium over the standard deviation of portfolio's excess returns. Right? So based on that, we already have the expected return on the risky portfolio, and we know the expected return on the investors. So the expected return on the risky fund, and the expected return on the investor's portfolio. Okay? We also know the standard deviation for the fund, the risky fund, and we know the standard deviation for the investor's portfolio. So based on that, we can calculate. So these are the numbers here for the investor. The expected return on his investment is going to be 14%, and the standard deviation on his investment is going to be 18.9, right? For our risky fund, we have the numbers here. The expected return is 17%, and the standard deviation is 27%, right? So I can say Sharpe ratio on the risky fund, we called it P, so I'll say SP. The risk premium is going to be the expected return on P, which is the risky fund, minus the risk-free rate, right? All divided by the standard deviation of the portfolio. Okay, all we need to do now is just substitute the expected return on the portfolio here on the risky fund is 17%, right? And the standard deviation, the risk-free rate is 7%. So in the denominator, we're gonna have 17% minus 7%, and the standard deviation is 27%. Okay? You can either substitute in percentages or in decimal places. It doesn't make a difference as long as you be careful and make sure that both the numerator and the denominator have the same format. Okay? As long as the numerator and the denominator have the same format, you're fine, because it's a ratio at the end of the day, so you're gonna get your answer. But the problem is that sometimes students would use percentages, for example, at the bottom here and decimals at the top, or the opposite. All right, so you're gonna need to be careful with that. Now I'm gonna run the numbers in my calculator and figure out the answer. So I'll say 17 minus 7 divided by 27. And the reward to volatility here is gonna be 0.37, okay? 0.37, so I'm gonna round it up to 0.4. Okay. And for the client's portfolio, we denote it as C. The expected return on the complete portfolio minus the risk-free rates divided by standard deviation of the complete portfolio. We substitute. The expected return on the client's portfolio is 14% right here, Okay, so that means 14% minus the 7%, which is the risk-free rate, okay, all divided by the standard deviation of the complete portfolio, which we have already calculated here to be 18.9%. So 18.9%. Okay, run the numbers. 14 minus 7, all divided by 18.9. Okay, and we are going to get exact same number, which is 0.37037, which we also going to round up to 0.4. Okay, so as you can see, coincidentally, the Sharpe ratio, or the reward to volatility ratio, is going to be identical for both scenarios, for our risky fund and for the investor's complete portfolio. All right. Okay. Now let's look at the last requirement here. D. It says, draw the capital allocation line of your portfolio on an expected return / standard deviation diagram. What is the slope of the CAL, or the capital allocation line, and show the position of your client on your fund's capital allocation line. Okay. Now the slope is already given because we figured out the slope in the previous stage. The slope is the Sharpe ratio. Okay, is the reward to volatility. So the slope is going to be this, right? But let's just draw the diagram quickly. I'm really, it's highly unlikely that I ask you to draw a diagram in your exam, but it's worth knowing. So I'm gonna draw my y-axis here and our x-axis here. Okay, on the y-axis we're gonna have the expected return, and on the x-axis we're gonna have standard deviation. Okay. For us, we are mainly interested in 2 points on the standard deviation axis, which are the 18.9%, which is the complete portfolio's standard deviation, and the 27%, which is the risky fund's standard deviation. Okay. On the y-axis, on the other hand, we are interested in 3 points. The 7% return, which is the risk-free rate, and the 14% return, okay, which is, if you remember, the client's return right here, and 17%, which is, let's say, it's somewhere around here, which is the risky fund's rate of return. Okay. Now the client's portfolio is going to be where? It's going to be in the intersection points between the 18.9 standard deviation and the 14% return. So somewhere around here, right? And the risky fund's portfolio is going to be somewhere in here, in the intersection between 27% standard deviation and the 17% return. So around here, right? This is the complete portfolio, and this is the risky fund, right? Now we're just going to sketch our capital allocation line. Hopefully I'm getting this. Let me slope it a little bit and then we'll move it. because we need it to pass through both lines. Yeah, approximately, but I'm gonna have to erase this and change its position because we need it to, or we need the line also to intersect with the y-axis at the point of 0 standard deviation with the risk-free rate. Okay, it has to intersect with the y-axis at the 7%, which is the return on the risk-free assets. Okay, and the slope, there is some methods to calculate the slope. You could use the slope formula to calculate, but in this scenario for the capital allocation line, okay, the slope is equal to, let me call it, or let's just put a bracket here. So this is the capital allocation line. The slope is equal to the Sharpe ratio. Okay, so what was it here? 0.3704. Okay, so 0.3704. All right. And if you want to be a little bit more fancy, you could go ahead and connect the points if you want. It's not really necessary, but as you can see, the rate of return of the complete portfolio is here between the 14% rate of return and with a standard deviation of 18.9, and for the risky fund, a standard deviation of 27% and a rate of return of 17%. Okay, that's how you can sketch this, and this is how you solve a similar question. It's relatively long, but hopefully this video helps you understand how you can go about solving such question. I hope that you found the question or the exercise walkthrough useful for you, and I hope you enjoyed this series. Until I see you in the next chapter's exercise solution series, hope you have a great time. Thank you so much for watching. I'll see you in the next one. Take care.